Hello, how are you? Because I've started recording, so I'm using my FM radio voice. My wife gives me a hard time, so when I pick up the phone, I use like a professional sounding voice.
That's my mom.
And she's like, why are you talking like that? Because this is how I talk on the phone. And Catherine's like, that's not how you talk on the phone to me. You're not a stranger. All right, so anyway, starting with the easier triangle, a 45, 45, 90 triangle. What do you know about that triangle right now? Where's the 90 degrees?
It's the hypotenuse.
It's opposite from the hypotenuse, right?
Yeah.
So here's our 90. Everyone is cool with that, yes?
Yeah.
Okay, what do we know about the other two angles in this triangle? They're 45 each, right? Now, what kind of triangle does that make us? It's two kinds. It's a right angle triangle, which means Pythagoras will work. But more importantly, it's a very special kind of right angle triangle, an isosceles triangle. What does an isosceles triangle let us know? Because not only are those two angles the same, something else is the same. What? The lengths of the legs, right? So this and this are the same. Do you know right now, without measuring, what those leg lengths are?
No.
No, indeed you do not, right? So what would we give it in math since we don't know what it is? A letter. And what's the letter we always use? X. So this is X and this is X, correct? Which means how long is the hypotenuse?
X squared plus X squared equals the hypotenuse.
Close. Talk to your neighbor. Figure out how long the hypotenuse is right now.
X squared plus X squared equals...
All I know is about
Oh, that's good tea.
when you have two legs together, you say
Dance break.
look at it.
Random dancing. I got music in my head because I'm that happy.
These two
What the heck kind of peel is that? What was that? The bottom vegetable. That was an orange? That's a crazy ass orange peel color. I've never seen an orange that particular color. It looks more tangerine-y. Well, I thought grapefruit too, but it was too small to be a grapefruit.
They might be making it too grapefruit.
I told you that about my kid, yeah? I cut him up some orange that he thought looked like a grapefruit because it was a weird color, and then he wouldn't eat it. Then I got all mad at him. Well, yesterday I found out he made a sandwich. He made himself a peanut butter sandwich. But we had some cold cuts in the fridge that had to be used. He was too lazy to use the cold cut, so I had to make a sandwich today. So the right thing got used.
But peanut butter and jam is so much.
Okay, are we done? Have you got this figured out?
He's avoiding the subject.
Okay. Well, first of all, what mathematical tool? You're a mathematical tool. Joke never gets tired. What mathematical tool did you bring to the party to try and figure this out? Pythagoras, right? You bring your buddy Pythagoras. And your buddy Pythagoras, the way you were taught, a squared, b squared, c squared, right? The way I like to do it, L leg 1 squared plus leg 2 squared equals h squared, yeah? So what is leg 1 here? X. What do you got to do with it to Pythagoras it? Squared. So this guy is x squared plus x squared. What's x squared plus x squared? 2x squared. And what's the last thing you need to do? Square root it. Yes? So everybody is happy that that is the length of the hypotenuse. Is everybody cool with that? Yeah? Cool. Okay. Now, what if we actually do this? What do we really have under there? We've got an x squared and a 2. And I'm looking for the square root. So can I get any of that out from under the radical sign? What is the, don't write this down, what is the square root of x squared?
X.
X. So you all know that, right? So I can pull an x out of there, right? Okay. If I pull an x out of there, I'm left with a root 2 under there, yeah? Can I get that root 2 out? Does 2 have a square root? No, it doesn't. It's irrational, right? Because square root of 2 is 1.414, blah, 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 right? Okay, so everyone's aware of that, yeah? So no matter what I do, I'm going to be left with a root of 2 under there, yes? Right? If I make this 25, this is 25 squared plus 25 squared, which is 2 times 25 squared, isn't it? I can get the 25 out. What's left under there? The 2. Everyone is okay with that? All right. So that's what makes this triangle particularly special. If I make this 1 and I make this 1, then what is this? The square root of 2. Always. Okay? Everybody with me? So no matter what, I'm going to be left with a square root of 2 under there. Now if I make these sides both 50, right? It's going to be 50 times the square root of 2. But it's still going to be square root of 2. Everybody understand? Cool? Yeah? Yeah? Okay. And you also know this from other things. For example, if my theta equals 45, what is my tan theta? Opposite over adjacent, and what is it? What's opposite of the 45? X. What's adjacent to the 45? X. What's x divided by x? 1. Okay, what's 1 divided by 1? 1. What's 50 divided by 50? 1. So no matter what I do, this triangle works. And as Case has said in the past, I can extend that triangle to any length. If these are both 45, this holds true. Everybody understand? Cool? All right. Now, what happens over here? 30, 60, 90. Well, the 90 doesn't move. Where is the 30? Think of what you know about angles. Is 30 steeper or shallower than 60? Shallower. So which of those two angles there must be the 30? The one on the right or the one at the top? The one on the right. So here's 30 and here's 60, yes? Everybody cool? Okay. Now, if we were to do trig with 30 and 60, we would find some weird stuff. What is the sine of 30? You can use your calculator to do it. What is it? 0.5, yes? Yes. 0.5. Now, 0.5 isn't a number we like to use for trig, is it? Because in this trig, now that we've moved on, we're using fractions again, aren't we? So what is that as a fraction? 1 over 2. What else is sine? How else have we defined the sine of an angle in this unit? A ratio. A ratio of what to what? 1 to 2. What if it's any triangle? What is the ratio?
3 to 45.
That's for Pythagoras. What is the ratio that we use for sine all the time? Because we could have used it over here, and it wouldn't have been 1 to 2. What would it have been? Sine is, pardon? Opposite over hypotenuse. Everybody with me? Everybody cool? So what then, in a 30, 60, 90 triangle, what value must be here? If the sine of 30 is 1/2, what value must be here?
15.
Opposite over hypotenuse. What value must be here? If the sine is 1/2. 1. What value is the hypotenuse? 2. Which means we can now find this, can't we? What is it?
1.
What's this guy's value here? How do you find the third side of a triangle when you know the hypotenuse? 1.7-ish, right?
Yeah.
But that's no good because we're ditching decimals, aren't we?
Yeah.
Okay, so what is it? Square root of 3. No matter what. Just like over here. Okay? This is always going to be root 2 with some kind of coefficient, yes? The coefficient being how much bigger we made the triangle. So this is always going to be what? Root 3 with the coefficient depending on how much bigger we made the triangle, right? If the triangle's doubled in size, it's going to be 2, 4, right? Right? So that would then be double that, but the root 3 stays the same. Is everybody okay with that? So, what then does that tell us about these two special triangles? What is the tan? Oh, we won't start with tan. We always start with sine. What is the sine of 45 in this triangle? It's O over H. So what is it? What's the O? What's opposite the 45 in this triangle? I got all day, guys. You just did a quiz on this. What is opposite the 45 in this triangle? X or 1. What is the hypotenuse? Square root of x squared.
Yeah.
But we don't want an x squared in there because when I asked you what is the hypotenuse with x's, everybody sat for a long time until I said talk to your neighbor, and then it still took a while. So get rid of the x's, use numbers. What is the hypotenuse? Root 2, always. What is the cos of 45? One over root 2. And what is the tan of 45?
1 over 1.
1 over 1. Everybody good? Now you guys are smart kids. What's the one degree that we have not done any kind of trig with? What's the one measurement that we have done no trig with? Pardon? 90. We've done no trig with 90. Why? Look at this triangle. What would the sine of 90 be? Try it on your calculator first or look at the triangle. Either way, I don't care. Try it and tell me what the sine of 90 is.
1.
What is it?
1.
1. What is sine? Opposite over hypotenuse. So here is 90. What's opposite of 90?
Hypotenuse.
The hypotenuse. Right? So it's hypotenuse over hypotenuse, isn't it?
Yeah.
Which would be root 2 over root 2, right? So the sine of 90 would be 1. Everybody understand? We haven't talked about 90 before, but you're aware that 90 exists, right? We've already proven that all the other degrees on 360 have a sine and a cos and a tan, don't they? But I haven't talked about 90 yet because I was waiting to get to here. Makes sense, though. Opposite is the hypotenuse, yeah? Cool? All right. So what then is the cos of 90? Go to your calculator and find out what it says. That makes little sense, doesn't it? Why would it be 0? What is cos? Adjacent over hypotenuse. What is adjacent to 90? Is this adjacent to 90? Is it? Mm-hmm. Is this adjacent to 90? Mm-hmm. So which one do you use? Well, you can't use either one. Cos is adjacent over hypotenuse. So can you do cos of 90? No, because there's two adjacents. You can't do it. It makes no sense. Cool? Okay. And what is the tan, then, of 90? It's an error. Why? Why doesn't it exist? Look at the triangle. Why can't I get a tan of 90? Pardon? Because it's opposite over adjacent. Which is opposite? Which is adjacent? You can't do it. So it doesn't exist. Everybody good? Yeah? Okay. Come over to here. What do we know about 30, 60, 90 triangles? What is the sine of 30? You've got the triangle right there. Tell me what it is. 0.5. Okay. With your calculator. What is it from the triangle? Right? And on the triangle that we have drawn right here, what is it? 1 over 2. Right? What is the sine of 60? Pardon? Uh-huh. From the triangle? What is it from the triangle? Well, don't look at me. You drew the triangle down there. What is the sine of 60 from your triangle? Root 3 over 1? 2. What's the sine of 90? We've already talked about the sine of 90. We don't need to do them. What is the cos of 30? Root 3 over 2. What is the cos of 60? One over 2, yay! And what is the tan of 30?
1 over root 3.
1 over root 3. And the tan of 60?
Root 3 over 1.
Root 3 over 1. Everybody cool? Now how can we apply this? We're going to turn the page over and we are going to apply it. Well, we're going to start applying it. This is what we use for exact values. And this is the way that you figure it out. You follow those steps. You already know what that's going to look like. So the first thing we do is we draw our quadrants and we draw our terminal arm. Where is the terminal arm? For 45 degrees. Where is it going to be?
The second quadrant.
Second quadrant. For 45?
No,
First quadrant. Right here, yeah?
yeah.
The reference angle is the distance to the closest x-axis. 45, right there, right?
Mm-hmm.
Which automatically means 1, 1, root 2. Right? Because it's one of those special triangles. So what is the sine of 45? What are the two ways we know how to do sine without a number? What are the letters that we would put in there to do sine? What did we start the unit with? O over H. What was our next thing that we did last couple of days?
Y.
Y over R. And today, we put numbers into there. 1 over root 2. Cool? Everybody good? Okay. Now 60, you've already done that. I'm going to change color. Where would 60 be?
First quadrant.
First quadrant, but it's going to be steeper. It's going to go up there, right? There's my theta. I want the cos of 60. We know that to be a over h. We know it to be x over r. And we also know it to be 1, 2, root 3. From what we just did, right? On the previous page. So what is the cos of 60? 1/2. Yeah? All right. Those are the two easy ones. You guys have a look at C and D. They're going to be slightly different. I'm going to make C right here in blue. And I'm going to do D over here in green. So what do I need to do with C? Draw my quadrants. Where is 330 going to be? Fourth quadrant. It's going to be down here, yeah? What is the reference angle? 30. So it's a 30, 60, 90 triangle, right? So it's 1 root 3, dummy head. 1, 2, root 3. What is the tan of 330? Remember, tan is over a, y over x, or, in this case, it's a tricky one, opposite over adjacent.
1 over root 3.
So close. What quadrant's that in?
4.
Is tan allowed to be positive there?
No.
So what is the other thing I need to remember? Not only do I need to remember 1 root 3, 2, I need to remember what?
It's negative.
That one, something in there is negative. What is it? Negative 1, because I dropped down 1. That's why the y and the x comes into play. Everybody cool? See how we add one little thing each day? The first day we talked about terminal arms. Now we're talking about how it can apply to everything, but we got to remember the directions. So now you should be able to handle D pretty easily. What's D? Quadrant 3. So it's going to come down here. So it's 225. So what's my reference angle? It's got to be 45, right? So now I remember, okay, wait, directions matter. That's negative 1, root 2. So what is the cos of 225? A over h, x over r, or how far did I go on the x-axis? Negative 1. What's my r? Root 2. Done. Everybody good? Everybody good? Okay, do E, F, G, H. While you're doing them, I'm going to be writing down the right answers. Try them. Yeah, that was funny. You can talk to each other. You don't have to be silent. I'm just going to shrink that down. Okay, I'm just going to shrink this down a tiny bit so all 4 of those answers fit on the screen at once. And I'm going to highlight them so they pop out for you guys. Everybody got it? He asked questioningly. Now, the question becomes simply this. Why am I able to rocket through this? What's the only difference? I have the same knowledge you guys have. What's the only difference? I've done it. I've practiced it forever. I don't see the quadrants. I see, 60, triangle turns. Okay, it's only practice. This isn't hard. It's all the SOHCAHTOA stuff you know, right? You're just piling it on more stuff and using it in different places, which is kind of the point. Trig applies all across many aspects of the mathematical universe. I am almost done with you guys today. Then I'm going to shut my pie hole. Can everybody follow what I've done there? Remember, the list of what to do is at the top of the page. So,
F, the angle be 60. There's
210.
Yeah, 270 minus 210 is 60.
But 210 is here.
Oh.
180,
Yeah.
210. Right? Okay. So I'm going to go ahead and erase E and do that one from scratch and talk you through it, okay? If you don't need this, don't pay attention. If you do, pay attention. Oop. Oop. Come on. Oh. Usual. Computer not working. All right. So I look at E and I say, all right, the sine is 240. So I start with my quadrants. Where is 240? See, this is all the stuff you need to know. Some of you don't need to hear this, some of you do. There's 180, but I got to get to 240, so I'm coming around. How much further? 180 is only 30 from 240? 60. So that makes this 60 degrees. Is everybody good to that point? Every single person? Yes? Okay. All right. Now, make this line. I've made my triangle, yes? Now, no matter what, you should be looking at that and seeing this makes this side shorter. Yes? And we know from what we just proved yesterday that once a triangle is 30, 60, 90, the short side is what? Go to what we just did. The short side has to be what? 1. So this short side has to be what? 1. Except, because we're on the quadrant now, the coordinate grid, that is not 1. What is it really? Why is it negative 1? Because I went left. So this is negative 1. Is everybody okay with that? Okay. What is the hypotenuse of every 30, 60, 90 triangle? 2. Where's the hypotenuse here? Right there. 2. And what's the third side of every 30, 60, 90 triangle? Root 3. Now, is that a positive or a negative root 3? Because if it's just a triangle, it's just root 3. But once it's on the grid, what is it? In this case, it is negative root 3. Now I want the sine of 240. So I need the sine of theta, which is what? Opposite over adjacent, yes? Opposite over hypotenuse, yes? So what is opposite to my 60? Negative root 3. What is my hypotenuse? 2. Is everybody okay now? Everyone is good? Okay. Come to here now, and we're going to reverse it. This is my cos. I need to find all the values of theta. Okay? I'm going to do this in 2 ways. One I'm going to draw, because some of you like it drawn. One I'm going to algebraically figure it out, because some of you use that. We're going to draw it first. Cos is negative. Right? So where is cos negative? C-A-S-T. Where is cos negative? Quadrant 1, 2, 3, or 4? Yo. That is from this day, when we proved that positive y, positive x, and a positive radius, everything in this is positive. All. Here, only sign can be positive, because opposite over radius. So C, or A for all, S for sine, T for tan, and C for cos. Everybody remembers that now? So, where is cos negative? Which 2 quadrants? S and T over here, right? Okay. So, and I know that it's root 3 and 2, right? 2 has to be the what? Hypotenuse, because it's positive, right? And it's on the bottom. So my hypotenuse has to go out this way, yeah? 2 and 2. Does everyone agree? It's the only ways it can go. Now make your right angle triangle. Which one's longer? This one on the left or this one in the middle? The middle one's longer, so there's your root 3. There's your 1. Is this root 3 positive or negative? Negative. Is this 1 positive or negative?
Positive.
Positive. And what's this one?
Negative.
I'm going to erase that T. Negative 1. Everybody cool?
Yeah.
So once I set that up, this is a 30, 60, 90 triangle, isn't it? This is the 30 degrees, yes?
Yes.
So how far is this? All the way would be what?
180.
But I've gone back how far?
30.
30. So this is 180 minus 30, which is
150.
150. Cool? Now I'll change color. What's this? How far is it to here? 180 plus 30, which equals 210. So what are the two values in our universe that will share that cos? Theta must equal 150 or 210. Does everybody have it? Everyone is good? Now, I said I would do it algebraically as well, didn't I? What is cos in algebra? It's x over r, correct? Well, I know the r always has to be positive, so I had to have an x of -3, yes? So that tells me I had to go left, right, to -3, which tells me that the triangle had to be this one. I don't even need to graph it, because I needed a -√3, which puts me out over here, which makes me know this had to be 30, this had to be 30, so I had to be 150 and 210. Okay? I recommend drawing these until you are very good at them. I can't stress it enough. Draw them, just like in your SOHCAHTOA quiz. Draw a triangle. So let's look at B. And I'm almost going to shut up. As I said, we've only got 2 more to do. How am I going to draw that? What are the things I got to ask myself? Is sine positive or negative?
Positive.
So where's the only places it can be?
1 and 2.
1 and 2. Right? So it has to go here and here. I can just draw it. It has to go there. What else do I know about sine? It's O over H, yeah? So what's my H? √2, which makes these both 1, 1, 1, 1. So what triangle is 1, 1, √2?
45.
45. So this has to be 45. This has to be 45. So what are the two options for theta here? Theta has to be, what's this?
45.
45. And what's this?
135.
135. Got it? So what then is tan of negative √3? Is it negative?
Yes.
So where is tan allowed to be negative?
2 and 4.
2 and 4. So it has to go through this way, doesn't it? Tan is opposite over adjacent, yeah?
Yeah.
So there's a theta, there's a theta. Opposite over adjacent. So this is √3 over 1, isn't it? So this must be negative √3, this must be 1. This must be positive √3, this must be 1. Therefore, what special triangle is that? What uses 1 √3? 45, 45, 90 or 30, 60, 90? 30, 60, 90. So that makes theta has to be what? Is it 30 or 60? 30, because it's the shorter one, right? So this is 30, this is 30. So what is theta? 150, because this is 180 minus 30. And what's this? 330. Why? Because it's 360 minus 30. Is everybody good? Holy crap. What's opposite over adjacent? What did I do there? What did I do with the triangle? It should be O over A, shouldn't it? What did I make O?
1.
Duh! What a maroon. It's from Bugs Bunny. So this is our 1, isn't it?
Yeah.
This is our √3. root 3, and 1. Oh, which means this is 60, isn't it?
Yeah.
60. So it's what?
120.
120 and 300. What a dunderhead. It's easy to screw up if you're not careful, yeah?
Yeah.
Right? Everybody good? Okay. Oh, I must restart my computer. Surprise, surprise. So I am going to stop there, and you guys need to then, I want for you, may I see one of your booklets? Gentlemen at the back, yes. Yep. Pardon me? This is positive? Well, no, because this would be -1, wouldn't it? And root 3 over -1 is negative root 3. And then over here, this is negative root 3. So negative root 3 over +1 is negative root 3. Cool? Okay. You guys don't seem to have the sheet I want you to do in this book. That is frustrating to me. Okay. You need then... Where did I put it? Where did I put it? You need this sheet. Okay. That's it. All right, guys, if you look on your outline, you see that we have just finished special triangles, yeah?
Yeah.
Okay. Now you have done no work with any of this for marks yet. All right? So I'm going to give you an assignment right now that covers all that. Okay? It will be due at the end of tomorrow's class. You'll have some time tomorrow to work on it. Yes. I'm not going to give you all 80 minutes to work on it because when I give you guys 80 minutes, I end up with 25 minutes of work and 55 minutes of garbage. So I'm going to give you some time to work on it tomorrow, 25 minutes. So how much of this do you have to leave tonight? 25 minutes worth. Got it?
What if we finish it all?
Then you finish it all and you'll have 25 minutes off tomorrow.
Okay.
Okay? Everybody Gouda? Okay, I'm going to go make these for you. I thought these were already in your booklet. They're already in the other booklet I printed. Can everybody flip through a little and make sure that L8, a sheet that looks like this, L7 and L8 worksheet is not in your booklet? You know, more proof. If you want something done right, you do it yourself. I'll be right back.
You know what I don't like? They're really wide. So if I get like right in there. What I like is that they're not. You don't like how it's thin there?
I like it this way. I don't want too thick either. Like the sushi, I sometimes eat random. Like I have extra sushi paper, tea paper, but it's just
Yes. Still.
rice.
Still.
Yeah.
It's like from doing the push-up on my arm. Not sitting my weight. No, everything. Like, yeah, all the way down, like all the way back. Yeah.
maybe stinks when I
Some of the abs. definitely did before I done this.
Bent down.
So I don't think it's like as
You're like, when you're running, you're like, pain. Next morning, you're done. When you're running, back to my house.
Oh, it's you guys. I was wondering what it smells like. It's still recording. Good job. Where's his pen?
It's like right.
Oh, it's right there. You can have that.
I have two. Actually, no, I have
Like even the next week.
How would you even do that to me?
Like I bet you're gonna win. Put your face in it. Smell the sweet. Die. I don't want to.
I need Norfolk.
What?
I need Norfolk. I want these. I want to get the ones that have like black and white.
We should do it and then erase it. And then
Like,
he'll see it through the video.
What has been done? We just have to dead. Not the whole thing.
I'm really tempted.
I know. But the second I touch something, it's
I thought that was him, but I was like,
But like, yeah, but I really want to get the.
what's going on? Dude, Christina, just draw smiley face. You gotta draw it in the corner.
He's gonna come back and say, "Who touched my phone?" I swear. The thing is that the fact that we're talking about this right now is so funny.
It's still there.
Yup, it's still there.
No, it's gone. Help me.
I'm always like really working it. Like, one time that happened to me, I think I ate apples. Like I ate apples. So I went to the washroom and then it looked like this.
I would have just started laughing. Like,
Cool.